In this video, we're going to focus on reference angles. So for every angle theta in standard position, recall that angles in standard position, or an angle is in its standard position when its vertex is situated at the origin of the Cartesian plane, and its initial side is fixed or coincides with the positive x-axis. All right. So the reference angle is the acute angle. It's always an acute angle, which is formed by the x-axis, either the positive or the negative x-axis, and the terminal side of an angle. Say in this case, angle theta. All right, so let's look at this angle in standard position, theta. All right, the initial side is fixed or coincides with the positive x-axis. This is the terminal side. Okay, the reference angle in this case is formed by the terminal side and the negative x-axis. Okay, so you look at an acute angle formed by the x-axis, either the positive or the negative side of the x-axis. Then that's your reference angle, say angle alpha. All right, same as with this angle in standard position, we have here angle theta. Again, the reference angle is formed by the terminal side of angle theta, and in this case, the negative x-axis. So again, you look for an acute angle formed by the x-axis, positive or negative x-axis, and the terminal side of the angle in standard position. All right. Same with this angle here. We have again an angle in standard position. Okay, so the reference angle in this case is formed by the terminal side. This is the terminal side and the positive x-axis. Okay, because this is the acute angle formed. All right. Therefore, this is the reference angle. Let's call it angle alpha. And then we have here another example of an angle in standard position. However, uh, this angle is measured through a clockwise rotation, right? And if you can still recall, angles that are measured in clockwise rotation are negative angles, right? But nonetheless, the basis for measuring reference angles is the same. All right, so in this case, we have here the angle formed by the terminal side, and whichever side of the x-axis will form an acute angle with the terminal side. In this case, the positive x-axis. Therefore, this is our reference angle. Okay. Again, let's call it angle alpha. Now let's look at some examples of finding reference angles. First, we are asked to find a reference angle of 150 degrees. To find reference angles, it is highly suggested that we provide a sketch, or we sketch the angle in the Cartesian plane, okay, so that we can easily find the reference angle. All right. So let's say this is the Cartesian plane. We have here the y-axis, the x-axis, and the origin. Okay. Now, before we continue, it is important that we take note of the values of the quadrantal angles. Okay, the quadrantal angles are those angles where the terminal side coincides with either the x-axis or the y-axis. Okay, so initially we have 0 degrees or radians. Okay, going counterclockwise, we get 90 degrees at the positive y-axis, okay, or the right angle, right? And then all the way through the negative x-axis, this will give us 180 degrees or pi radians, the straight angle, right? And then this one, the negative y-axis going counterclockwise from the positive x-axis, this gives us 270 degrees, right? Or 3 pi over 2 radians, okay? And then one revolution, of course, is 360 degrees or 2 pi radians, okay? So we have here, assuming uh, we have a standard, an angle in standard position. So this is the initial side, all right? 150 degrees, the terminal side of 150 degrees is roughly located here in the second quadrant, okay? So let's say this is angle theta, which is equal to 150 degrees. The reference angle in this case is the angle, the acute angle between the terminal side of angle theta and the negative x-axis. All right. So this one, angle alpha. Let's call it angle alpha. All right. So angle alpha in this case is the quadrantal angle here, which is 180 degrees. Right. So that's 180 degrees minus 150 degrees. All right. So angle alpha, or the reference angle, is 30 degrees. All right. Next, let's find the reference angle of 780 degrees. Okay. So again, we have here our Cartesian plane, the y-axis, the x-axis. Recall that one revolution is 360 degrees, right? So from, for example, the initial side, which coincides with the positive x-axis, one revolution is 360 degrees, right? So this is 360 degrees. Another revolution will result to 360 plus 360, that's 720. Therefore, 780 is somewhere here in the first quadrant, because if we add another 90 degrees, so 720 plus 90, that would be 810 degrees. All right. Therefore, the terminal side of 780 degrees is located or situated somewhere here in the first quadrant. All right. So this is roughly 780 degrees. Okay, let's call it theta equals 780 degrees. All right. Therefore, the reference angle, or angle alpha in this case, is the acute angle between the terminal side, so this side, and in this case, the positive x-axis. All right. So again, you look for uh, the acute angle formed. Okay. So this angle here, let's call it angle alpha. So alpha now equals 780 degrees minus 720 degrees. And this will give us 60 degrees. Okay, this is now our reference angle. Next, let's find the reference angle of negative 135 degrees. This time, we are given a negative angle. Okay, so from the initial side, to measure negative 135 from the initial side, we rotate on a clockwise manner. Okay, so let's say this is our Cartesian plane. This is the y-axis, the x-axis, the vertex which is on the origin, and the initial side. Okay, so again, negative angle, the rotation should be clockwise. Okay, so going clockwise from the initial side, this is negative 90 degrees, right? If we go all the way through the negative axis, x-axis, this will give us negative 180 degrees, right? Therefore, negative 135 is located or situated somewhere here in the third quadrant. Okay. So let's call it theta equals negative 135 degrees. Okay, and the reference angle in this case is the angle formed by the terminal side and the negative x-axis. So this angle here. Again, class, you look for an acute angle formed by the terminal side and whichever side of the x-axis, as long as it forms an acute angle. Okay, so again, let's call it angle alpha. To solve for angle alpha, or the reference angle, recall that uh, this angle here from the initial side, the angle formed at this side of the x-axis, the negative x-axis. And with respect to the rotation, this is negative 180 degrees, right? This is negative 135. We can just subtract 135 from 180 to get angle alpha. Okay, so 180 degrees minus 135 degrees. Okay, to get angle alpha. So alpha now is 45 degrees. Okay. Next, let's determine the reference angle of negative 13 pi over 6. This time we are given an angle measure in radians. Alright, so Cartesian plane, y-axis, x-axis, vertex at the origin, okay, initial side. Now, 13 pi over 6 is more than, some degrees more than 2 pi, where 2 pi is the radian equivalent of 1 revolution. Alright, and remember that the angle is negative, so rotation should be clockwise. Right, so from the initial side going clockwise, 2 pi is 1 revolution, right? So this is 2 pi. Okay, again 13 pi is just some degrees more than 2 pi. However, if we go all the way through this quadrantal angle here, it will result to 5 pi over 2, which is more than 13 pi over 6. Therefore, 13 pi over 6 is situated somewhere here in the fourth quadrant. Okay, so let's say this is the terminal angle of negative 13 pi over 6. So here, okay, so this is theta equals negative 13 pi over 6. The reference angle in this case is the acute angle formed by the terminal side and the positive x-axis. Okay, so this angle here, let's call it angle alpha. Right, to solve for angle alpha, we just subtract 2 pi from 13 pi over 6. Okay, so we have here alpha equals, we can take the LCD, 13 pi minus 6 times 2, that's 12, times pi. Therefore, alpha is equal to pi over 6 radians. So as a summary, to find reference angles, you look for the acute angle formed by the terminal side and the x-axis. Okay, either the positive x-axis or the negative x-axis. And also, regardless of the sign of the angle in standard position, like this one, so regardless of the sign, the reference angle is always positive. Okay.